So a loan class is a debt provided by one entity to another entity at an interest rate. So loans can be repaid through a one-time or several regular payments. So we will be working on calculating several regular payments for this discussion. And an annuity is a sequence of equal payments made regularly. The amount of each payment is referred to as regular or periodic payment. And in this discussion, we will denote this by capital R. So an example of this regular payment is like, for example, car loan. So car companies offer car loan. At most, customers can pay that until 5 years. So usually it's a customer would pay monthly. So would be paying a regular periodic payment. So usually it's paid every month, but other customers can be given an option depending on how they can pay conveniently. But usually they offer that on a monthly basis payment. Okay. So here, so a smartphone in our previous discussion is purchased with a down payment of 1,000 and the balance will be paid at 1,075.83. And this is monthly for a year. So what is its cash price if the interest rate is 6% compounded monthly? So what we're going to do is to combine the down payment plus the present value of the balance, okay? And that is done using this formula. And this is P for present value. And the R here is the periodic payment. And then our M here is the compounding period. In the compound interest problems, we have made use of the variable N for the compounding period. Here, we're using M for the compounding period. And in this problem, M is 12. Now, substituting the given in the formula, we have the value of R 1075.83, and then our M is 12. Annual interest rate is 0.06. And placing all of this in your calculator, rounding off to two decimal places, so we will come up with 12,500. And the cash price, so what is asked in the problem is the sum of the down payment and the present value of the balance. And this will lead us to the cash price equal to 13,500. Next is, okay, Sheila borrowed money from a bank which charges interest at 10% compounded quarterly. So she agreed to pay the principal interest in 36 payments of 7,000 at the end of every quarter. So this is quarterly payment. So this is not 3 years. Instead, this is four times, because we have 4 quarters in a year, right? So we'll divide 36 by 4. So this is a 9-year loan. Okay, so how much did Sheila borrow? So we're asked to solve for the present value. So the amount of money that Sheila has borrowed. So our R here is 7,000. And then substituting the given in the formula, we have point 0.1 is the annual interest rate over 4 since it's quarterly. And then to the negative 36, we have 36 equal payments. So meaning we have 9 years and 4 quarters. So that gives us 36 equal payments all over zero point 0.1 over 4. So P here is equal to, let's solve together using your calculator. 0.1 over 4. So this is 164,893.76 rounded up to two decimal places. So this is the amount of money that Sheila has borrowed. Okay? And that's the present value. Now, in our number three problem, semi-annual payments of 56,000 pesos are used to repay a loan at 7% interest compounded semi-annually for 4 years. Find the original amount of the loan. Again, this is working on the present value. Okay, so this is the annual interest rate. And then this is the periodic payment, semi-annual payment. So substituting the given in the formula, so this 56,000 class is the periodic payment, 56,000. And then 1 minus quantity 1 plus, the rate is 7% all over 2 because semi-annually. We have 2 semi-annuals in a year. Okay? And then to the negative, so that's 2 times 4. No? So this is negative 8 because this is TM, time times compounding period. All over 0.07 over 2. Okay? So let's make use of our calculator, round off the value to two decimal places. So 56,000 quantity. So we have 384,941.51. We are expecting a huge amount since, as you can see here, the periodic payment is 56,000 pesos. So in a year, that total to 100,012 or 112,000. Okay? And that's for 4 years. So if you want to know how much was the interest earned, you may add, you may multiply 56,000 by 8, and that exceeds the amount of money that she has borrowed. So the difference would be the interest. Okay? Now, amortization class is a debt repayment scheme in which the original amount borrowed is repaid by making equal payments periodically. So usually it's monthly. Find a monthly amortization for a 150,000 debt which is to be repaid in 2 years at 7% interest compounded monthly. So here, we're going to work on the periodic payment this time. The formula, this one was derived from the present value formula. Okay? So solving for the periodic payment is done using this formula. And 150,000 here is the present value. And then this is the annual interest rate. Monthly, so M is 12. So this is 150,000 times 0.07 all over 12 all over 1 minus 1 plus, this is 0.07 again over 12 to the negative. So this is 2 times 12, 24. So the periodic payment is equal to 12 over 1 minus 1 plus 0.07 over 2 to the negative 24. So this is 1,556.82. Ito yung monthly payment niya. And this is payable in 2 years' time. Mm, let me check. Wait, I think I was just able to press 15,000. Wait. Okay. So substituting the given here in the formula, solving for the periodic payment. So we got instead 6,715.89. And this will be paid for 2 years monthly. Now, an amortization schedule class is a table showing how a debt is completely repaid through periodic payments. So part of which go to the interest payments and the other goes to the principal repayments. In large companies, of course, they make use of an application, amortization calculator to work on the progress of the payment. So for now, we're going to use calculator. So, we're going to use that example, 65,000 loan at 12% compounded semi-annually is to be amortized every 6 months for 3 years. So, find the semi-annual payment and construct an amortization table. So, there will be a total of 6 repayments because it has to be paid semi-annually. So, there are 2 semi-annual in a year times 3. So, 6 payments yan. So using R, for us to solve how much would be the periodic payment. So we have, this is the present value. So 65,000 times, this is 0.12 interest rate over 2 all over 1 minus quantity 1 plus the rate is 12% over 2 again to the negative 6, 2 times 3. So we have 65,000 times, this is 0.12 over 2. And then all over 1 minus 1 plus 0.12 over 2 to the negative 6. So we have 30,218.57. 6 times this would mean payment for this loan. Okay? So this is how we create an amortization schedule. First, we prepare the table with the indicated column headings and 7 more rows. So this is the periodic payment, no? So we calculated for this earlier. Okay, so we're going to place the periodic payment. As you can see, this is constant from period 1 up to period 6. I told you that there are 6 payments, repayments, because this is semi-annually and then 3 years to pay. Now, as explained, the interest will partly go to the interest payment and repayment of the principal. As you pay on the principal amount, the outstanding balance decreases until it reaches the value of 0 on the last payment. Okay? So, step 2 would be place the original debt and the periodic payments. Okay, so ito yung periodic payments natin and then this is the outstanding balance or the original debt. Oh, no. Next is step 3, get the interest payment for the first period. Subtract this from the regular payment to get the principal repayment for the first period. Deduct the principal repayment from the debt to get the outstanding balance, the new outstanding balance at the end of the first period. Okay. So, how much are we going to pay for the interest? That's the question. So, interest payment for the first period. So, this is equal to the principal amount. So, we'll make use of the simple interest, no? This is I equals PRT. So, the outstanding balance is the principal amount and then the rate. The rate has to be divided by 2 since semi-annual kasi siya. And the rate is this is an annual interest rate, right? So, how much again was the interest rate? Let's check. 12%, no? The interest rate was 12%. Okay. So, this is 0.12 divided by 2. Or you may write 0.06. So, 65,000 times 0.06, 3,900. So, that would be your first payment to the interest, no? So, this is 3,900. Now, the principal repayment will be the difference of the periodic payment and the interest payment. So, using your calculator, never end using your calculator. So, we'll come up with an exact value always. But we will round off the value on the table. So, for example, in your calculator, you have an input of 3,900. What you will do is input 13,218.57 and then minus answer. So, that will um, record 3,900. So you have 9,318.57 as your payment to the principal amount. When you add the two, it's the periodic payment. So the new outstanding balance will be 65,000 less the principal payment. So in your calculator again, 65,000 minus answer. So equals the new principal amount, the new outstanding balance. So that's 55,000 681.43. Calculating the interest payment again. So, for the second payment or second period, so the outstanding balance should be 55,681.43 times 0.12 over 2. So in your calculator, you have the entry for 55,681.43. You just press times 0.06. 0.06 is 0.12 over 2 equals. So you have the second interest payment, 3,340. So this is 0.89. Let me check ha. Here. Ito siya, no? 3,340.89. And then, we will subtract this from the periodic payment. So in your calculator, your last entry was 3,340.8858. So what you're going to do is again input 13,218.57 minus answer. So you have 9,877.68. This one. And then subtract this to the principal repayment and you'll come up with this value. Okay? So you have 9877.6842 in your calculator. So what you're going to do is press 55681.43 minus answer. So you have this value. Okay? So, tingnan ko lang yung next slide. Okay. For the third interest payment to the principal, so this is 45,803.75 times 0.12 over 2. So in your calculator, your last entry was 45,803.7458. So you multiply that by 0.06, which is actually 0.12 over 2, and then equal. So you will have 2748.22. So you will place that on the interest payment third period. 2748.22. And then subtract this from the periodic payment. In your calculator, enter 13218.57 minus answer. So you have 10,470.35. And then subtract this or subtract the payment from the outstanding balance. So you will have to input 45,803.75 minus answer. So you'll have 35,333, tatlong 3.40. So to obtain the interest payment on the fourth period, so this is I sub 4 equals 35,333.40 times 0.12 over 2. So you're going to multiply the 35,333.40 by 0.06. So you have 2,120.00. And that is your interest payment on the fourth period. So this is 2,120. And then subtract this from 13,218.57. So input in your calculator 13,218.57 minus answer. So you have your principal payment 11,998.57. And then subtract this from the outstanding balance. So in your calculator, you input 35,333.4 minus answer. So you have 24,234.83. So in solving for the interest payment on the fifth period, you have 24,234.83 times 0.12 over 2. So in your calculator, you just multiply the last entry by 0.06. So you have 154, 1454 rather, 0.09. And that's the interest payment on the fifth period. So this is 1454.09. Subtract this from the periodic payment, so you'll get the principal repayment on the fifth period. So this is pressing 13,218.57 minus answer. So you have 11,764.48 as the principal repayment. And subtract this from the recent outstanding balance. So you will input 24,234.83 minus answer. So you have 12,470.35 as the outstanding balance. So Finally, calculating for the interest payment on the 6th period. So this is 12,470.35 times 0.12 all over 2. So in your calculator, you just input times 0.06. So you have 748.22 as the payment to interest. So this will be 748.22. Subtract from 13,218.57. So this is 13,218.57 minus answer. So you have 12,470.35 as your payment to principal on the last period. And then subtract this from the outstanding balance and you will end up with a zero balance. Okay? So we have this one already completed after the 6th period or after 3 years.